When you fire it up, this is a RAM standalone version of the RAM connection, and you need to be signed into your RAM Bentley login, and you're presented with an interface like so. Most of the buttons you probably won't deal with most of the time. So we start with the connections template. So if we click on the connections template, it shows what templates are going. And that's a clue to how this software works. It works by picking out a ready-made template, a template of connections that they know have worked before. And then you compare it with the loads that you've put in. Similarly, sections. Here is my library of sections. Well, I don't want the US, I want Australian connections because that's what we're going to be using. Materials, we've got Australian materials in there, so they're likely to be the typical range of material types we use in New Zealand. And similarly, the connection types are the templates that we'll be using to define our connections. And similarly with bolts, we want the Australian code for bolts, Australian sizes, and so on. So similarly with welds and anchors. So for this part, you'll probably never use it again once you've set it up. And hopefully your administrator of your IT will have already set this up properly. So we have a blank screen at the moment, and it has multiple ways of doing the same thing. So if you want a new connection, we click on the button marked New. And up pops a selection of different types of connections that you can design with this software. The software is limited. It doesn't do every connection and every possible permutation, but it does a number of standard, typical connections that you'll find in steel construction. So top of the list is the beam to support, and you've got various ways of connecting a beam to a column, or beam to a beam to a girder, and so on. You've also got splices and column tops and bottoms, as it were, the column cap and the column base plate, as well as vertical bracing or horizontal bracing, and then truss components. So this is quite useful for tubular trusses. Let's start with something simple. Here is a beam to support, and we'll go for the most basic one, a beam to a column flange. So let's select that. Now, if you punch in the data, click on OK, or click on the next arrow, we find it's picked out your beam size, and it's picked out a 310 UB32 size, simply by default. You can change that from the pull-down menu, make it either bigger or smaller. Let's make it a little bit smaller, click OK. And by default, it's picked out the 350 material. Well, you can change that to 300 if you so choose. Similarly with the column, you have a prismatic member. It's picked out a UC 200 UC 52.2. And again, you can change that by the pull-down menu. And you can change the grade in pretty much the same sort of fashion as done before. So there's your beam and there's your column. Now you would be tempted to go on to the next part, which is loads, and that would seem the obvious thing to do. Click on loads, and you're presented with a sheet for putting in your loads. Now, you can only use one load combination, the load combination that you've defined for this set, and at the moment you haven't defined any load cases. But if you've designed your connection or you designed your frame in another package, that will spit out the loads that you can use in terms of a loading envelope. So you might be okay with just one load case in there. So handily, they have help files. And the help files are context dependent. So a little bit of help will pop up whenever you put information in to Bentley RAM Connect. There isn't a generic file called help for the whole system. So you have to do it bit by bit. But Now we've got V2 and we can look on the diagram. Oh, look, the beam has a V2. Let's give it a value of 35 kilonewtons. We'll give it a nominal axial load, as we can tell from the diagram. We've got 0 moment because it's a pinned connection. Look at the column. Well, we'll probably have a nominal 21 kilonewtons of shear, and the axial load we'll put is 67, quite randomly, and again a 0 moment. So if I click OK to that, it presents me with this image, and that shows me I've got a column and I've got a beam, and that's about all it says about it. It knows it's going to be a beam to column flange, but it doesn't tell me how I'm going to design it or check it or what the value is. So again, we've got the templates on the right hand side. Well, we can ignore those if we wish by clicking the template button off. On the left hand side, we have our a picture of the connection we're going to design, and it tells me it's not designed. So we can go straight to the design, or we can add some more loading. Now, if I click on the add/edit button, it tells me I can add load conditions, and by default I've got 1. So what you can do is add load cases, and these tiny buttons down here allow you to apply a number of different load cases. So by default it gives you dead load, but you can add live, snow, wind, and so on. So if I click add into there, similarly with load case combinations, I can either delete them or I can add them. And give it a dead load of 1.2 and a live load of 1.5 factored in there. So it's already given me one combined load case at the ultimate limit state. So the generate load case combinations doesn't actually work for New Zealand codes. Okay, so now what do I do? Well, I want to apply something to it, some bolts, some cleats, and so on. So I might want to click on the design tab. It's not fairly obvious that. So thankfully we've already got it defaulted to NZ3404, and we assign by clicking on the assign button. Now there's a number of different ways of doing it, and again you're pulling from libraries. You've got the basic connections, the smart connections, and the user connections. Well, surprise, surprise, there are no user connections. After a while you may be able to build up some user connections. What's the difference between the smart and the basics? Well, it's a bit like the difference between manual transmission and automatic transmission. There are a number of the standard libraries which you can optimize, and if you pick a smart connection, you will also get a button marked optimize in there. So if I go stick with my basic connections to give me a bit more control, the first out of the box is an angle cleat. So if I click assign to that, and that assigns the angle cleat to the column. Okay, now by default it's showing me down in tiny letters on the left hand side 0.4 of my user case. Okay, so how do we know what's going on? Well, there are two routes to get to the details of this. One is you can click the edit button and open the edit function, or you can double click and that reveals a new window which gives you access to a 3D view of your connection. So you can pull it around by twisting on the axes, or if you click on the big cube, you can take some standard views. So there we have our standard views, and you can scroll in and scroll out. So across the top, we have some basic information, such as save, print, print a file, and so on. The interesting ones are the results tab and the data tab as well. You can change the view that you're looking at depending on which button you're pressing here. I prefer the solid view. More importantly, on the right hand side you have a number, a 0.4. The 0.4 is the utilization factor of this connection. So it's less than 1, so therefore it might indicate that the connection works. However, it's not green, it's kind of orange. So it's giving you a warning. On the left-hand side, we have all the information about the connection. So we start with the members, which tells me about the beam that we've selected. Have we coped it? In this case, there's no copes on there. Also tells me about the angles. The angle is picked from the library as 100 by 100 by 8 equal angle. Okay, by default, it's picked out an M20 grade 8.8 bolt. So it seems okay so far. So what's wrong? Well, let's click on the results button. Now pops a report. So this is your RAM connection report about this particular connection. It tells you what the input was. I only put in the dead load, which has just been factored. And I've got lots of green ticks, but a couple of red crosses. So it's checked the support flange end distance and the angle thickness it doesn't like. So it would appear that my connection is strong enough, but it doesn't actually fit and it doesn't comply with the detailing. So let me close that and go back to the potential design. Now you could play around with the size of the cleats, or you could do something else. You could change the type of connection you've got. So let's come out of that by clicking the cross, and I want to assign the connection to a different thing. So let's go for a flexible end plate instead. So that's now been assigned. Double click to open it out. Let's have the 3D view of that connection. And now you can see I've got a 0.29 capacity, utilization of the capacity. So if you look at the results, I've got the same sort of information now, but with lots of green ticks. In fact, the utilizations are also quite low. But if you're happy with that, just go ahead, print that out and save it. So you can save it as text or put it into Microsoft Word or Excel, or you can just print it to PDF or to your printer. Fair enough. Or you might want to change it because that's not very efficient. So your end plate, scroll down here on your left, you've got an end plate thickness of 8 millimeters, and you've got M20 grade 8.8 bolts. Well, let's see how low we can go with that. So let's go to the other extreme. Let's try M12 grade 4.6 bolts. Now, it's still telling me it's working. So I've got a 0.69, so it's working a bit harder now in there. And as you go, the help file will pop up and it reveals itself down below. And it's also context sensitive. So when you're looking at bolts, it will show you the picture of the bolts. Hopefully, if you're looking at the plates, it tells you about the plates. If you're looking at the longitudinal spacing, it tells you about the spacing, gives you a picture of each of the bolts. The other button on here is the data. So if you click on that, you get a report for all the input data. So that tells you all about the beam and the end plates you've entered in here. Okay, so that's relatively straightforward. You've designed your connection. If you've made any changes, don't forget to save it. Otherwise, you'll be lost when it comes out. That will be lost. So you've got two views here, and you can have the 3D view that we've got, or you can switch to the DXF view. If I switch off the help, you get a full page. So this will allow you to export this connection to your drawings, your CAD files as well. Close that, we come back to our connection. So that's the basics of RAM connection software. And in common with many Windows software, you have open, file, save, and so on down your left-hand side, and it follows the ribbon method. But it also presents you with some recent models. So here's something I prepared earlier. I won't say the one we had. Here's something I prepared earlier. So I've got a whole range of connections. This was for a real project about a year or 2 years ago. And some of them are relatively straightforward. So here is my BCW, my beam to column web. And it tells me here that I've got a 0.99 utilization factor. Now, that may or may not be true, depending on whether you've got the critical load connection actually set. If you find that the number there is different from the number you work out in your second screen, then you've not probably picked the critical load factor. And you can go on to slightly more complicated connections, such as this bracing connection in here. So I've got tubes connecting to a beam. And if we go into the details of this, you can see things can get quite complicated. But interestingly enough, I've got another button now, and it's called the Optimize button. And if it finds that your utilization factor isn't the factor you want, i.e. you're too large or even too small, you can click on the Optimize button to rationalize it. But it's still telling me, even though I've optimized it, I've still got a warning about edge distances. So you might want to do something about that. Unfortunately, because it's a smart connection, you can't. You've got limited editing rights over this one. So we could go on with all sorts of things with this software, but I'll just close that and leave it to you to explore.